Good morning, I am Dr. Lalrinpuia. On behalf of Government Sampai College, I extend a very warm welcome to all the participants to the first day of 1 week international webinar on natural disaster with special emphasis to earthquake and its implications. And also a hearty welcome to all the resource persons, our speakers, who have agreed to make this venture a success. First of all, I would like to request our principal, Mr. P. Lenming Liana, Principal of Government Sampai College, to give the inaugural speech.
First of all, today I want to thank God for giving us a chance to conduct the first webinar in our college. As we know, this year we are fighting the pandemic of
Audio in mute niya.
running age status in 1978. It was again provincialized on 1st January in 1989. We have 4 streams of education such as arts, science, computer science, and commerce. Altogether, we have 14 subjects now. At in 2016, for the second time, and we are given B+ grade, securing 2.78 CGPA. The theme of our webinar, natural disaster with special
International webinar and boss saya
as earthquake occurs times in our of Mizoram. I hope we are benefited by this webinar. I wish the webinar a success and gladly open this webinar. Thank you.
Thank you, sir. Now we shall call upon Mr. L. Kumavarte, Professor and Head, Associate Professor and Head, Department of Geography, to deliver a keynote address.
Thank you, Madam. Today, at this moment, wholeheartedly, I greet all the participants of our international webinar program on the natural disasters. Thanks to the developers of the internet system that during this pandemic period and its consequent lockdown, this kind of program can be arranged. I also thank the organizers of the program, Dr. C. Liana, Lalrinpuia, and Van Lalrinpuia, for giving me this opportunity to give the keynote address. Further, I also want to thank the organizers for selecting a very appropriate subject, that is, natural disasters with special emphasis to earthquakes and its implications. Of the many different natural disasters, it is very befitting to select earthquake as it is a burning issue in the present day Mizoram. A very large number of the population of Mizoram, especially those of the Sampai district, are panic-stricken due to the recent earthquakes. The last earthquakes of which we felt the day before yesterday night. More than 65 earthquakes were already being felt during June and July alone. The focuses of these earthquakes were not deeper than 25 kilometers, The magnitudes were not higher than 5.3 on the Richter scale. Most epicenters were confined within the southern half of the Champhai district, and only few of their tremors were felt beyond the district. Still then, walls of buildings cracked and collapsed, and they have to be dismantled. Landslides and rockfalls were found on the hillsides. Cracks have been developed along metal and unmetal rods and so on. It's been more than 1 month that villagers of the district, so many villagers of the districts, dare not sleep within their buildings, but they have to sleep outside the building, constructing some tents in where they think are safe for them. The state government, church organizations, NGOs, and educational institutions stepped up to offer financial supports and countenances, and also to comfort them, the panic-stricken villagers. The psychological impact of the people is worth mention, but thanks to the Almighty that no casualty have so far been reported. The general public of Mizoram, being literate, are mostly aware to some extent that the whole state is located over a weak geological structure. The Yangfall mountain ranges of the northeast India, starting from Arunachal up to the southern tip of Myanmar, is called as Purvanchal by the geographers. This mountain range extends from Arunachal Pradesh in the north, Nagaland, Manipur, Mizoram, and the Arakan Hills, which extends up to the Cape Negrais of Myanmar. These elongated hill ranges were the outcome of the compressional forces between the two plates of India and Myanmar. Myanmar portion is a part of the large Asiatic plate. The two colliding tectonic plates causes the emergence of the hill ranges, and there are fault lines which are found in the eastern margins and the western margins. Geologists talked about the possibility of severe earthquakes along these fault lines. 8 of the magnitude, the earthquake magnitude is expected to be 8 in the southern margin and 7 along the eastern margin, and this type of high magnitude will cause severe consequences for the whole of the northeastern hill ranges. The subduction of Indian plate being heavier and heavier due to the deposition of these big rivers in the plains of Bangladesh and that of West Bengal causes heavier and heavier geological formation in the eastern parts of the peninsular India, and due to this, the subduction penetrates below the plates of Burma. Well, let us keep those things for our experts, our resource persons. But now, today, I'm very, very glad that we have as our resource persons our reputed geologists, reputed geomorphologists, geographers, representatives from the United Nations, and psychologists and other expertise speakers from different colleges and universities within and abroad the country. I shall now conclude my short speech with a hope that our experts will enlighten us deeper and further into the natural science of our active Earth. Thank you.
Thank you, sir, for enlightening us with the theme of the webinar and explaining to us further how the subject of today's webinar is really the need of the hour. Now we shall come to the technical session. Today, we are pleased to welcome our first speaker, Dr. C.Zoramthara from Government Zirtiri Residential Science College. Dr. C.Zoramthara has done his PhD from Mizoram University and specialized on sedimentology and structural geology. He is an assistant professor and head of the Department of Geology at Government Zirtiri Residential Science College. He has published 6 research papers on journals and edited books. Some are impact factor journal like Nature, Scientific Report, Art and Planetary Science Letters, etc. He has presented 7 papers in international, national, state, and regional level seminar and workshop. He has done 2 research projects. One is Tectonics of Indo-Burma, collaboration with Lamont Doherty Art Observatory in New York, George Mason University, New York, and Radford University, funded by National Science Foundation, USA. And the other research project is classification and mapping of different types of mass wasting in the northern part of Aizawl, Mizoram, India, under Department of Science and Technology, Government of Mizoram. At present, he also serves as a consultant at Zofa Consultancy Firm. And today he will be sharing with us his expert opinion on tectonics of Indo-Burma range. With that, I ask all the participants to give your full attention and help me in welcoming Dr. C.Zoramthara on the webinar platform. Please, sir.
Good morning, all. Thank you for inviting me as a presenter. I want to thank the coordinator, all the and Sampai College for organizing this kind of international workshop. Mizo tongin ngen hi kan soi me nga hi en tu tam jok ten hi Mizo tong an share thiam jok don awangin ti request om awangin ya hei tunna ya lir ming ten sa em ya chu wang chuan tuna workshop in organize Champhai College in organize tha ka ti khop me ya chuan voin ya hian kan na te le kan lo research sang kan lo ti ve te athiang angin hemi webinar kal tang hian share kan tum ve chunga chuan ka topic tur hi tectonics of Indo-Burma range ti ani a ti ha kan mu them ke ke hi najina rong soi to han Dr. C.Zoramthara, Assistant Professor and Head kan nia Department of Geology Geodetic College tu na hian ko meka chuan tuna ka topic rong soi tur hi Indo-Burma range kan ti hian najina han kan principal za takhan rong soi fia to thawa hi hemi Bangladesh atanga Myanmar inkara kan leilung in khe chho dan velte Department of Geology
so ram khoma ini slide current set
chuan
slide hi ron lang lo he
alang em o ti han
lang lo
ala lang lo tlat
so ram khoma ini slide current set
chuan
mute đây lo putong te hian yo hi mo hi ni ba mo screen share chu eng lo nga ya PPT khalo lo ka nga ya mo
ti han alang to em o
ne
lang ne
okay thank you alang tro
oh
ka tong in thre them o am I audible kan chun zom leng o Tectonics of Indo-Burma range di hi ka topic rong soi tur nia ma se tectonics ti ringot po hian soi tur tam tak oma ta hian engeni i ama sign tectonics ria thiam tum photila tectonic kan ti hian enge a soi tum ber kan ti chuan he kan lei chung langa a lei sakhat alung sakhat ho hemi a chet dan velte tin ba ka a lei lung in thua thip dan te khatiang zong zong kha tectonics kan ti chona huam vek mea tin ba ka engeni kan lei lung in nek sora wanga tlang lo in siam te khatiang zong zong te po kha tectonic process a chona huam tel vek mea tin he tectonics kan ti hian surface atanga kilometer zavel theng te hi a huam theya tin he tectonics hi chiang tur chuan internal structure of the earth kan ti lei chung ril om dan te ha kan hriat le nga ya chu han soi fia le don taila e tuna alema kan huang hian e hi diagram re hi amol theang berin angeni azir velem no pon a hriat the thiam thei turang khan diagram hi kanong da a hi kan huang hian khovel hi zeibung mok taila ti hian in thua thip sang lo oma chuan achunga kan huang hian crust mantle core in ein thenta ni chuan kan crust an ti hi hemi kan lei sakhat kan tuipui huai lei thua thip te tin kan tlang tin hemi continent kan ti zong zong te hi a huam vek ani he crust hi tuipui huai hi chuan a cha zong hi paria ta tanga som 8 to 10 kilometers vel ania chuan khomwala ve thung hi chuan kilometer som hi tanga som sari te tin tlang sang tak tak anga te pe chuan kilometer za don te po han hol ve the ni chuan hemi hnuai chi crust noi a hian mantle kan neya ma se he mantle hi engeni he kan khovel hi zeibung taila za a som riat deuh to hi he mantle hian a o a chuan hi crust atanga mantle inkar hi a cha zong hi kilometer sang ni zakwa angvela chut ni a chuan he mantle hi achunglang lampang han asthenosphere kan ne he asthenosphere kan ti hi he layer hi lung sakhat ni lowin tlemin tuiril deuh ma se engeni tui anga omno isi lo engeni hoizu angvel hi niang chu khati ang han asthenosphere layer hi oma chuan chumi hnuai le chuan core kan nei le kan core hi kilometer sang thum le core le inner core kan nei he core hi tlang puin iron le nickel ina siam ania hemi chunga hi chuan pressure asan to em awangin pressure asan to em awangin thil sakhat ang vekin omani chuan he internal structure hi kan hriat chian anga ya engwai nge plate tectonics ti te po tu na ya kan thrilar ema khatiang zong zong kha engwai nge kan leilung hi hetia achet vel ti kha hriat tur chuan internal structure hi kan hriat ma saka ngai ani kwa som pahnih khan alfred wegner hian theory pakhatalo propose to chu continental drift theory atia chu a theory propose a chuan na chuan kan khomwal te hi hun khata an lo om vek thina our continent ti in antia chuan chu mi nuwa chu Pangea lo in Pangea tin an ko chuan he Pangea te hi alo ke dara chuan local kwal vela tuna kan khovel leilung omdan khomwal le tuipui in thenang hian alo in then ta ni atia ma se he continental drift theory hi khongain sar te han min mute sak them
Ki mo sir.
sar te han min mute sak them a beng seng riau me
Sorry.
ole lo me continental drift theory hi nia hi Alfred Wegener na rong propose hian in hial na tam taka oma thenin oya thenin oilowa ani hian han proof na turatan han fossil te amanga tin fossil sa han animal ran nung te tin thingkung atang te khalan manga ti khan thil chi sang tang khalan approve na han tia ma se oi tu le oi lo tun an lo tam khop me ni ma se Alfred Wegener hian asoi theilo chu he continent he khomwal pui ama om khom the engwai nge an ke dara an tol son ti ha achan ha asoi theilo ni he theory a hian chuan tuna alema kan huang hian hei million zani somni panga kalta chuan kan khomwal te hi pakhatan lo om khom veka chu Pangea an tia chuan million zani vela chuan aloke shet ti han aloke a then marlama te atola then chimlama then chaklama ti han atol shet ta ti chuan a noi per kan huang hian hi present day ti alem kan huang chuan khu tuna kan khovel omdan alo ni ta ni chuan hi Alfred Wegener theory chunia ni ma se ka soi tawng khan he khomwal te engwai nge tol son ti kha Alfred Wegener hian a soi fia thelo ni chuan sang khan chukwa somsari bor vel roin her chho chuan has 10 plate tectonic theory anong propose ne ta ni heta hian plate tectonic theory a hi chuan he kan na chin kan soi crust le upper mantle na chin alema kan lo ti lang to kha mi te le sakhat chin kha kilometer khomwala le tanga kilometer somsari te athena chun za don te poni thea khang ho lithospheric plate kan ti ho kha ingeni bu he khovel hi ake nuaya plate sang thaina zom khomani an ti kha anong propose vele ta ni chu plate te chu tui chunga vur kalkwal velang hian akalkwala ti khan atol kwal ti kha anong propose ani chu ta chuan chu plate tectonics theory ti na rong anong soifia ta chon he plate tectonics han plate kan ti chuan nge kha crust le upper mantle kan soi to le asakhat chin cha tak tin a then lai chuan pan deuh te polo ni ve a cha zong kha chuin ang vek lo ta khovel mun sang changa ai nang lo ani kha plate ta kha mumal takin apian te kha om lowa tin asakhat ema khami mumal lo tak in nek sor wang te po han tuna kan riat angin lir hing kan ti te poilo om thin ani chuan kha plate kha athena chuan lian pui plate lian pui ni line athena chuan te ro te ke them ang neuh te pon oma chu major plate te minor plate ti ten an soya major plate hi kan nei tam lo ani khovela hian hei po hi plate za te hi school of thought sang oma athenin pasari om an ti line athenin pakwan om te an tia ma se kha chu enga polo ni se plate kha thiam khotila ti khan athen chu lian pui te nia antina na African plate ti te North American plate ti te chu plate lian ania chuan Nazca plate te kha tiang chu plate te ni le ta ni chuan tin plate kan ti the ka soi tawng han a cha zong hi ang lowa i oceanic plate an ti tuipui hnuaya lung sakha tho kha chu apan ani a cha lo ani ni ma se athena chuan kilometer som panga te ni thei line continental plate kan ti khomwal lama plate ve thu hi chu cha pui te pon om ve thea tlanga sang pau le arut among lampang po halo cha ve zel ti kha kan lo bok don nia chuan tuna alema kan huang hian hi plate sang te chu nia Eurasian plate te Pacific plate te hetiang hi plate lian ani South American plate ti te North American plate te liana African plate te tin Nazca plate te khi chu te ta ni ti han Scotia plate te plate sang kha oma an chon he plate te hi athena chon in suwa athena chon in kal thela he plate in Sudan te hi tuna ani adot le kan en chiang zel don nia zona omta chu tu na plate tam tak athen lian pui te athen te ro te kha engwangin nge khatia athena in kal thela thela in sutti kha zona lian tak khalom ta ni chuan hei hi nia tun theng po hian afik fak taka soi thei tak chun omlo ma se mi rin dan le scientist an zir to china chuan convection cell wangin omani ti hi asthenosphere na china khan art internal structure ha kan tilang to le chung ril om dan ha ta han asthenosphere layer te pok an ti lan to kha khami tang khana chianga khami asthenosphere han convection cell kan ti hi oma chu zoi muang hian so kwala khami so kan lung nuai lama lut tha ho te ha khatia ho te ha alo so kwal ta ni khami so kwala wang han he convection cell hi alo omani antia scientist ten chu po chu ni le he so kwal hi eng angwanga rong so nge ni ti te ha zona ha om le ta chon radiogenic disintegration awangin he convection cell hi an siam ni ti te po ha theory te po omani chuan he convection cell hian kan nei chung rila sa kha kan surface leipon langa rong ken chuak tumin arong vir chuak thina zoi muangin he avir chak zong hi a chak lo khop me kum khata centimeter sombang a chakin avir lem lo ni chuwang chuan so tia khan so bula kalkwal hal vut ni lowin so ma se zoi muangin a so tin kan soi tong khan mental cha zong ni 4 kilometer sang hi sakwa laya thuyani wang khan zoi muang na kalani chuan he convection cell wang hian divergent plate boundary anti plate le plate in kal son na la ya chuan ti khan makma harong chuaka lava ang ten roin he kan surface ate rong chuak thin ta ni hi tuna kan hmu theng hian ale ma hian rong jiak chi ka rong da chiang khop me hei aveilam panga hian wooden block kan ti thing block kha tui chunga lang ani chon tui kha gas a khan han chuang ta la tui kha so chon akal kol pup pup ma chon achunga thing om hi chu ti khan ati kwal mai don ni khatiang chi kha hi convection cell kan ti kan plate ri tak cha tak te lo thoi kwal tu hi kan plate mentala hian noilam panga plate noilam panga mentala hian asthenosphere layer a han e convection cell hi omani ti kha scientist na an soi dan chu ni chuan tuna kan huang hian hi plate boundary sang kan nei te nia divergent plate boundary kan ti a chon a chung ber alema chung ber hi plate le plate in kal thel na lai kha nia convergent plate boundary a chon ain su ve le thu ni plate le plate in suwa chuan heta hian kan hret tur poimo chu plate le plate in sut khan an density kan ti an muk zong te an sakhat zong te an lo wang khan a density sang zok a muk zok a sakhat zok a hnuaya tol luta chon a density hiam zok kha a tol lut lo wa chon ma se hemi wang hian hetiang lai hmula hian clear hinga tam tu em a convergent plate boundary hi seismic activity tam na lai khovel hun sang a poni chuan a dot le chuan transform plate boundary kan ne hi chu in kal thel kan tiang chi khan ta he in kal thela hian example a chuan khovela lar tak San Andreas Fault kan ti te po ku he transform plate boundary hi nia a in kal thel dana hian a ding zonga in kal thel te a vei zonga in kal thel te oma khalai kha apoi mo thina ni lin hing zir na konga chuan convergent plate boundary hi uluk dewin lo en chiang ila a chan chu hemi convergent plate boundary hi tuna kan Mizoram scenario tak ani wangin convergent plate boundary a hian chi sang pathum kan nei le ta ni oceanic crust le continental crust in sut na lai chu tuipui nuaya kan crust ale kan khomwal kan leilung sakhat kha ain sut khan oceanic crust kan ti tuipui a leilung kha a density sang zo ka wang le ambuk zo ka wangin a hnuaya tol lut thin ta ni chon ale ma kan huang hian hemi alu thak hian partial melting an tia he atmosphere le azuk thlen hian temperature san to em wa in ti khan tlem alo tu ya tlem azong chon tlang kang te rong sima chu wanga volcanoes nei thin te kan ni tlang kang nei thin kan ni ti chuan adot le a oceanic plate ain sut hian hi example la chon Japan achung ber hi South American plate le Pacific plate in sut na lai example la chon Peru te Chile ate lir hing kan nei tam na chan kha nia alaya mi hi Japanese plate kan Japan earthquake kan nga na chan kha nia Pacific plate in sut na lai ki di lai ang kinia oceanic plate in suwa ti khan a density sang so ka ha noya to lutin tlang kang rong siama Japan te poki volcanic island kan tiang chi kha heti ang tlang kang atanga in siam ang khania chon heti ang lai huna han lir hi hina se em bokani chon ato pera hian continent to continent collision an dia hi continental crust le continental crust kan le khomwal kan plate te pani ain sut khan heti ang chi hi continent collision an dia anoi ber amiang hi helai taka hi tuna India plate le Eurasian plate in suta wanga Himalaya tlang ro in siam san te po heti ang hi nia tin Mizoram te tin Indo-Burma range kan ti te po hi he Himalaya tlang in sut in siam na chunjom na southern extension ani themem ti te po hi tuna hian ani em ti te kan soi jaw don nia ti chuan a basic deuh rekin khan kalanga faulty structural geology tel lo chuan heng zong hi olsam takhana soi theilawa chuwang chuan longai thatu ten uluk takin longai thaila faults kan ti chuan hi geological structures ania omzia chu ile lekha po ding le ve ikut ding le ve khan han won la han nor tom lang chuan aloin thep me ni I force pek dana zir zel khana in thep soi nen thep soi don lo ni ngil takai pek chuan I fault kha ein thep po khan alaya je muk taila I fault kha ein chen che nom the don ni chu symmetrical fault kan tiang chi the khania khat chu fault kan ti chu engeni geological structures ania engeni wave ang me hian tian asang le ahniam lampang te neya ma se heti ang fault hi atlang puin compressional stress an tia chu in nortom na tha awanga in siam ani chuan fault a hian common deuh pani kan neya anticline le syncline hi alema tang hian han soi fia do ni la tuna hian alema kan huang hian kan lei lungte aloin nortoma aloin the hian asang lampang hi anticline an tia chuan ahniam elaya kan huang hian hi syncline ania asang lai hi anticline kan ditani chuan he fault hi compressional force anti in nortom na tha zir khan ai nortom dan na sat dan na zir khan aloin thlep kwal thina ni kan lei lungte aloin thlep thei khop me hai an hnuai kan huang hian hei hi lung tak ania mihring atang hian a lei lung alen dan tur zong te khatiang kha kan se thei menga hei hi alema kan da hi isotline recumbent fault kan ti khania recumbent fault hetiang hi tlang in siam na mun leilung in nortom na anga om du ema chuan he fault ang awanga Mizoram tlang dung te poi chim mara om vek kan ni ti pona kina chiang zokin kan la soi fia turanga yang atot le a chuan fault kan tia a mi hin ang em mea FOLD le FAULT ti hinia han soi do nok pon shet pol hi ol thina ni alam dan ni na a pronunciation ain an em awangin chuan fault kan ti FAULT ve thung hi chu lei khichat fracture kan ti khatia han engeni che om chi han fault kan ti tani lei khichat kha a khik ringot kha chuan fault kan ni chuang lawa crack kan ti mo khatiang khani meya amo joints kan ti te po hani theya ma se che om chi khan fault kan ti hi ni tani chon chu fault hi chi sang om theya a then the pe chu kilometer tam tak kilometer sang te po a hol theya a thena chuan kilometer ko hol lawa meter ni thumlek te po ni the ni chuan he fault bang hian block pan hi lo in then don ti na ni chu a chet chi khan atlan hiam ani mo a chho zo ina kal ni mo kha block ate kha a chet dan hai ang lo ta chu wang chuan he fault hi an chet chi a fault len le len lo dana zir te pon earthquake kan ti lir hing siam tu poimo tak khan ni fault te hi ti hana le ma hian lo en le taila hemi tang hian chiang anga ama sabera chuan fault ti sang kan nei nai ma se apoi mo tlang pui a general do lek ka han enfia do nanga ama sabera chon reverse fold kan nei ni reverse fold ta ve hi chuan leilung te kha a inkal thel dana ha a che dana ha block pakhat zo hi a chho ta dei ta ni ama sabera lem kan huang hian hei reverse fold ani a block hi pakhat helam pang avelam pang mi chho te ya ading lam pang atang hian atanga te chon avelam pang hi chho ta ni a dot le a chuan normal fold kan tia hi normal fold ta chuan velam block velam pang hi ading lam pang atanga te chuan atla thavele thung ta ni heti ang chi normal fold kan tia chuan strike slip fold ta ve thung chuan ding lam pang block ding lam pang le velam panga in kal san dana hi a chung zong ani mo a hnuai zong ani mo in a chel ve lo wa he ve thung hi chu a in kal thel zong in a che ve thung ani strike slip fold hi chuan hei a hnuai kan huang hian lema hian he lai korsen ha pakhat din na hi kan huang hi fold scarp ania hei tu na hian mishing chen deuh thoin he leilung hi tla hiam ti na ni hei normal fold ani chuan apia le a hian lo en le taila hei te po hi folding wangin he leilung avar vek hi tiangil vek om tur hi hei ain kalson ain dei ta hela alaya mi a block hi atla tha ti na ni hei normal fold tho ni ali ma tang hian chiang tura ngai la chuan kan topic a lu chodon taila Indo-Burma range kan soi to ang khan hemi zong hi a tectonic hre thiam tur chuan tuna a ma sa kan soi ang chi plate tectonics te tin structural features folding te kan hriat ma saka ngai chu wang chon kha man mo taksin kim lo taksin ka han soi thuak ania enge Indo-Burma range kan ti chuan Indo-Burma range hi thlang zong a lei in thlep ani do tlang puya trust belt kan tia fold trust belt om dia chu lachina alem kan en tong khan leilung kha ain thlepa ain the mei baga han lei khichat che kha om bok ani fold kan ti kha om boka chu fold trust belt an tia ain nor toma wanga om ti na nia chuan he Indo-Burma range hi Sunda subduction zone atangin atanga Himalaya inkar vela om hi ania ain zom vekem ti te po hi tun thleng hian research a hian ngai zirmek ania atam zok pom na chuan Sunda artenen po in zom vek ngai ani ti chuan heta hian accretionary prism kan tia accretionary prism kan ti chu nachina khan kan hmutoa crust kha hi leichung lang sakhat ho kha leichung lang sakhat ho hi khatia plate le plate abikin Mizoram hemi Indo-Burma range scenario bi ka chuan alem kan en to khan continent collision kan tiang chi continental plate le continental plate in sud in north tom na layanga khan a plate a rit zo ka kha a density sang zo ka kha annoya lu tha chuan khami an lu thak rual khan a chung langa sediments kan ti lei takho mang chi teng het lawang chi ho kha khatia ho kha alo in north tom thinta chu tiang in north tom taka chu accretionary prism kan ti hin ta ni chuan Indo-Burma range po hi accretionary prism ni in a zau zong hi kilometer zathum somnga atanga a then thei chon zari te po antia atlang puin zathum somnga atanga zathum som sari panga angvela ni chu tia anga zau chu ania chu wang chuan Indo-Burma range kan sui re chon Mizoram chu alak theilo ti kha kan lo hre don nia chuan he Indo-Burma range hi engwai nge apoi mo a tuna hian tun workshop te po engwai nge kan nei kan ti chuan ka soi to ang khan Mizoram chi ha en theilowa Arunachal Pradesh te Manipur te tin Assam te tin chaklam panga Myanmar te tela tin thlanglam chon Bangladesh te tela tin keni Mizoram te po kan tel ta ni chung zong ami pui om za te tuna hian atlang puin million za somli ai tam turanga yan nia chung ho om khom na chuan lir hing kan ti mega trust earthquake he fault trust awanga earthquake lir hing om thei ang chi ang ania wang khan apoi mo sia mi pui mishing cheng kan tam sia chu wang chon helai mun hi zir chian apoi mo ni ti kha scientist te ngai dan ania tin Indo-Burma range kan poi mo na chia po chu ani chon hei tuna lema kan huang hian hei Indo-Burma range le abul ngai vela om te nia hei hela ya hian Himalaya kan hua chon a chak lama hian marlama Himalaya kan hua tin Indo marlama tho ma se Indo-Burma range lai seta Shillong Plateau kan hule ta ni he Shillong Plateau te po hi allowin uplift dia chu allowin vor chuak to a tin he lama Central Burma Basin kan ti te kan huwa hemi tang hian tuna asena in hung chu hi Indo-Burma range kan ti chu ni a ale ma tang po han en wang po hian ki kan tlang dung re hi chim mar joina kal uta ma se thena chon chim mar kan ti two north south direction ha ani lowa thena chon chim chak zonga hoi te po oma hi tlem na hoya hi achan gan soilenga engbai nge ki tia a om kan ti chon he Indo-Burma range in next or na hi ngil taka in next or ni lawin a in thuai te lawanga ki tianga kan tlang dung te po athen lai a chuan chim chak zong hoi te oma athena chon mar thlang zong te pon ti han a hoi ni ti chuan a dot le a chuan he kan leilung hi zirnan a che dan vel han zir hi apoimo ema he hi antinge an no zir kan ti chuan geodesic an tia chu kan leilung che dan te tin kan leilung che dan engzo in nge a che mar zo nge che ta chim zo nge thang zo nge che ti zirna kha geodesic an tia tin baka hemi me baka arts magnetic field kan tia kan leilung hibna te po ha geodesic hian a form tel vek ani chuan he geodesic a hian scientist na an man tangka an zir chen dana chu permanent GPS station ha khomwala hanan da thina ni chuan chu he GPS hi dakar som hi pali chung an on char dikhan kar khat chung ten khami chung khan leilung hi a che em che lowem ti kha an lo monitor chumi tang chon leilung che dan te khoi zonga che nge enganga chak nga che nge ti kha hriat the ni chuan Indo-Burma range te hi entinge allowin thlepa allow nor tu omani ti kha entie kan hriat the kan ti chuan ama sabera chuan hei India rama scientist tam tak te pon lo zira Dr. Gahalat VK Gahalat NGRI mi te pon helai Mizoram nge te tin northeast tam taka te po khot tam taka permanent GPS station hi nong da chuan tin Bangladesh lama US lama kan tho puiten GPS som thum pasari anda to boka tin French scientist ten Myanmar lama hian engmot zat anda an lo zir ve boka chung mang chuan he Indo-Burma range che dan te akal chak dan te hi an lo zir thin ani tin hemi che dan ringot pialam panga hian leilung in the dan te tin fault kan ti ein the dan pialam panga fault lei khi chat cheto ang chi te kha omem ti te kha hi apnuna kalkualin ti khan data lakwal ani boka chu an lak dana chu alema lo entai la hi permanent GPS station ania he permanent GPS station hi kan phone na GPS ang mei khani lawin accuracy hi sang em me ti khan he alema kan huang hian satellite GPS satellite pathum te hi tuna hena lema langa hemi chok lo poi satellite tam takoma he permanent station kan ti GPS receiver hian avar hela yami hian i ti khan leilunga nge takin an buna ti khan i dakar somni pali chung kar khate ka ni de tha te an lo monitor ta ni ti chuan a omna leilung GPS receiver omna leilung hi chelo chu ni se chuan i location i reading a ha i latitude le longitude reading kha ngai renga petur nia kum khat po ni se ni ma se kum khat chung khan ti khan an monitor khan Indo-Burma range ti alo che hret ani ti kha he GPS station atang hian alo hriat the ni adot le a chuan kan leilung kan lung te ain the dan te le le khit geometry entinge a geometry entinge ti kha hi ataka kalkualin te kwal vek ania he kan te kwal na hen nia kan beina save khop mes kum sang ni som pathuma tang khan kan beitana ti chuan sang ni som pariata paper pani vel chu kan pe thei to ka tu na hian ongoing paper omeka kan project hi kan na zo che lawa a zong chu tun voi nia puan kan na soi thei don lawa ma se kan ti to chin te kan tam theng ber soi kan tumanga chu ta chuan lung in kho dan a angle zong ate ain kho dan kha a on lo em ti te kan la veka chuan he lak dan hian engeni compass kan ti Branton compass le field move dino application hi mobile app ania mobile app mangin kan la he kan mobile app hi satellite ena in khun zomin tikhan map zong kan data zong zong kha Google Earth aroin plot ngal veka chuan chu mi tanga kan leilung in khedan hemi Indo-Burma range in khedan kan ti te po adota tilan kan tum don nia ma se heta hian kan soi le du chu he folding and folding geometry kan zira hi chuan hi hemi surface kan ti kan leipon la tanga kilometer thum te kilometer li vel thing bak azir thei tak tak lawa chu wang chon alei chung ril tak tak azir tur chuan engeni oil company ho ina oil an zon nana an man thinang technique sang sang thei man ngaya eni chuan tuna tak hi chuan kha kan manglem lo ma se hei chu surface measurement chian ni ti kha melo hriat chak le mok kula chuan hei tuna alema kan muang hian hei field move dino application chu nia ti khan lunga kan vata ati khan alung in kho on dan jong te eng zong in nge in kho a hoi zong ti zong zong te ati khan i data kha phone haro in save ta vek ani chuan hei kan field photograph ania ti hian Mizoram hi chimhar zonga tlangdung kalani wangin zeibung mok taila entinge tlangdung hi achung hi en thleng ti hretur chuan chakthang zonga kan kalangaya ti khan chakthang zongin motor kong po om manglo ate athei angin ti khan chakthang zonga kal khangai angai si wangin jipro ta te kan tana thena pe chuan kal thelo ke kalngai te oma ti khan Mizoram changni lawin Assam ate Manipur ate ti khan Tripura ate kan kala i data hi kan dakwala leipon lang in kheda ni ti kan han zir chiang ani chuan hei lai po hi Mizoram chung vek ani a chuan he lai h kan ti hi diagram figure h a hian kan hunga hei tut lui kulai ma mit tlang dung ani a he tut lui ina zo zai zai a hian fault lei khi chat kan huwa chu te po chu adot le kan na soi zau tura nga yang hei hi Indo-Burma range GPS manga anlo monitor to na ni a kan thopui steklar ten le lenado si paraten kumsang hi le so parukhan nature an publisha he data hi an ma ni chawin an ti theilawa Bangladesh lama an zirna te pialam panga India lama chon Dr. Vinit Gahala tate tin baka bang ani te pon bela tin Myanmar lama hian French scientist te an thopui pokani chung data tang chuan ei tuna arrow a ei hetia inko ka hi atol zong te hatiang hania Indo-Burma range tol dania chuan he lema hi uluk tewin lo entaila he lai a hian achak lama hian entaila sagyang fault kan hua he sagyang fault hi Myanmar ani dei to a he sagyang fault hi athui khop mea he strike slip fault ti in kal thelang chi kha ni chuan adot le ka bo fault kan hua he ve thung chu trust fault ania ka bo fault hi chu natina kan hmu to reverse fault alema kan hmu faulting sang kan hmu mi hatiang chi ka bo fault hi he trust reverse fault hi nia chuan Mizoram lampang hnaya hian Chorachanpur le Mawin kar hian Dr. Vinit Gahala taten hi fault an hmu chuak ani chu fault chu Chorachanpur le Mawin kar an hmu chuani wangin a hminga Chorachanpur Maw fault CMF ti hano phua chu CMF chu hei he ta kan hmuang hian Mizoram chak lampang Myanmar region ni sia hian he fault hi akal tharuak mea chuan he mat fault te hi he fault pathum te hi lo po hi he laya Mizoram a chuan he laya hian Mizoram tantlang do thoin awang zong in mat fault kan nei ni ti chuan he ta ma mit tlang dunga hian tut fault kan nei le boka a kha chuna kina kan na soi zau don nia chuan he fault hi lo thatiang khotila uluk tewin a chan chu tun lir hing chungchanga hian eng ho hian poimona tam takan neya chuan hei digital elevation map kan ti ni a DEM map hi lo en wang taila hi ta han kan tlang dung kan nei lung om dan in nek sor dan chu achiang to khatin a riat thea he kan huang hian ka bo fault he ta achak lama kan huwa Mizoram hnaya CMF kan ti tuna ka ko me ka hi hei Chorachanpur Maw fault hi ani chuan Mizoram a chuan he me pa chan fault lian chi kan da chuan kumsang ni le som parukhan he tut fault hi kan project atanga kan mu ania ma se ama te pon geologist dang tele company oil company yang te pon anlo mu to mai theya ma se literature a hian chiang taka da chola umlo wa in kenin paper a han da choka chuan he tut fault hi chu ma se reverse fault kan ti tho khania he kabo fault poi reverse fault tho nia CMF ve thu chu in kal thel kan ti strike slip fault ang chi khani chuan han en wang taila kan tlang dung hi he lai han aizol oma la hi leng tuian hia tlang dung hi chim mar zo ina kala ma se hun then khata roi chon he in thuai na kan hunga he in thuai hi om zia chu slide pakhata han kal le lok taila heta hian he GPS movement atang hian achian da na chu he arrow fei in ko hi hemi tang hian hi chakatang hian chakatanga thang zonga ngil taka rong nor ani lawa he hian arong nor kuala ni ti hi he GPS data tang hian chiang em ani chu wanga kan tlang dung te po he laya digital elevation map han kan hmuh he lai te po lo in thuai lo in her do ni ti kha thiat thei ta ni chon he mat fault zul zu yan fault te nau tam tak kan ne chu tun kan ne pai jok rong da chok lem lo antina na he lai hian champhai oma he lai champhai aphai zol lai nia he lai hian spray fault ti fault te ro te om chok ta ni he fault te hi he kan mat fault parallel che hena oma hemi chok lo wa po chim lama po he ta lung le thanga te long tlai pen fault te nau tak kan nei chu ni chu wang chon tun na ya pahat kan je du chu i fault lo rin top te an lo oma a tha thowa ma se fault varina ti tur chon thil tam tak ti ve nga ya ground checking ti te engzo nge he fault ti ain her ti te vazil chian phot lo chon fault ti rin ngot chin lo di ha kan bel tua tin fault zong Mizoram som ni pakhatom ti te kha hang te kha thu dik tok lo ania kan fault chungchang Mizoram chunga fault hoila yang he oma engchang he omti kan chiang du ni chon Department of Science and Technology noya mirsak Mizoram remote sensing in mapping thatak ania Mizoram sarkar department in mirsak ate po map lai turom fe ka ta han kan Indonesia ti ha kan soitel le du ni ti chuan hi component velocity field of Indo-Burma range ti nia he component velocity field hi apoimo khop meya hi uluk dewin lo zil chiang non taila nachina khan fault yan pui kan soi to sagyang fault te kabo fault Zoramthara ma fault ti te tin khang ho kha Mizoram atanga chaklama om fault kan nei ho ania athang lama te po fault ma he kaladan fault te kan nei ani ma se heng pathum the hi lo en chiang le phot la hi tuna alema kan thaibial alian puya sena kan thaibial sagyang fault kan ti hi he velocity component ta hian helai graph hi kan en chuan he tian he step ang me na kul ta ni he mi kul hi kha GPS kha he kan Mizoram Indo-Burma range hi apum puin kilometer zathum som sari panga vel bor hi kum khata hian Myanmar atanga heta Bangladesh theng khan ai nor chak zong hi kum khata millimeter somli paruk vela chaka in nor tom anga chu tani GPS data atanga zirtan chuan chu kilometer somli paruk in nor tom chu kum tam takalo in nor tom to chuan leilung khai khep duai don ni ti ha chiang rengani ma se chu ti rual chuan voini kan din huna chuan ama kan sreilawa voini kan din huna chuan i kha sagyang fault te kabo fault te Zoramthara ma fault wang te khan kha in nor tom na chakna tha kha he fault lekhi chathian alo absorb alo la thenani chuan hei kan hu ang hian graph kan hu ang hian he sagyang fault kan ti asena kan thai bel lian bera hian hei he graph hi tuma GPS velocity kha lo la then tuam lo se chon he graph ngil takin linear line anga kal chho turnia he tiang ngil taka kal chho turnia ma se tuna chon step angina kal tlat ta ni chuta chuan he chakna tha he akal chak zong hi he sagyang fault hian alo lan hem ber ti kha scientist ten an chu chuak ani chuta chuan sagyang fault hian 21 mm per year millimeter somni pakhat ang vel hi kum khata lo lak then sakani apum pui somli paruka han chuan kabo fault hian paruka tanga pariat vel la then anga ngai ania helaya hian chuan Zoramthara ma fault hian alo la nem le em ta hi helai a hian hei helai tang hian ten a chho do ra ma se hei sagiang fault nena kan khai khin chuan sagiang fault hian ala nem bera a do ta chon chora char purma fault hian 8 to 10 millimeter per year vela lo la ni chu ta chuan he CMF hi kan riat thei to china kum sang ni som pathuma han science direct Professor RP Tiwari tele Dr. Vinit Gahala te khan an publish to a chu ta chuan he chora chan purma fault Mizoram bula fault kal ruwa ka hian hi he GPS chakna tha hi engbo chen lo la than ma se hi ling chu rong la khen lo ni ti kha kum sang ni som pathum thenga an data kum som nga chunga an la ka chuan an la an hu chuania ni ma se chu tiang ani rual chuan kum sang ni le som panga te som paruk vela te pokan hrianga liran hing deta kan hria Mizoram te pon kan lo fil via chung chu khoilai epicenter kan ti chuan Manipur lampang te lo ni le thina tin atam jok chu Manipur le Myanmar lampang ania khang ha he fault sagiang fault des chorochan purma fault te active ani wang ani thei ani ti kha chiang em me a chuan he chorochan purma fault chu ka soi tawang chuan kumsang ni som pathum thleng a paper publish a kha chuan hingian tham engwa la siam lo tia ni ma se la sang ni som paru earthquake te kham Manipur earthquake te khan chiat na then dan he kan traffic anga khang kha chorochan purma fault ta tanga hing lo in i chuak ani ti ha kan lo chin sia bokila he fault te kan tan chuan an poimo em ani chuan fault trust belt model hi entaila in nor tom chuan hei hela ya hian ama sabera hian chung bera hian trust tip kan tia he a hring chin hi ai nor tom na chin hi hemi area ang chi hi asan ve zel kha ngai ta ni chu he fault trust belt ta hian a thena chuan lung khan hei a hian kan huwa ti ra chuan lung hi ten an in nor tom ve photan ni chuan a hnuwa chuan a thei to lo china chuan an le lung kha alo khichata fault kan ti ai a chung zonga in kal thua reverse fault kan tiang chi te kha om ta ni hetiang chi ABC lemang hi Mizoram a chuan atam em me a chu tuna hian a video in toite in han play tu mila alang the mo ti khan
lang thế alang e
ole video hi uluk takin lo enila hei tuna kan huang hian he leilung hi atira chuna tha lowa asang lam pang zo ka po 4.5 cm chi ania ma se ti khathian ai nor tom zela ti khan ai nor tom hian hi lung hian ai thlepa a thei to lo china hian scenery zel ki fault kan ti fa bel ti lei in kal thela che khan ta ni hi tiang fault hi lo siam chok ta ni chon heti ang din hun che hi tuna kan Indo-Burma range leilung in siam dan te tang in siam dan te nia chuan di hian trusting kan ti fault in kal thel ma se a angle zoom box hi tam ta khalo in siam ta ni chu mi be pe lama leilung khalo in thlep ne noi boka e ti han zoi muang in lo en le tai la hi a angle hi sang ti ha ro in siama a lai nor tom zel awang in ti han ni a thara ro in siam bel zel a fault te po ti chuan khi a stop angle khi lo en tai la ama ka chuan 0 degree do thonian ma se tu na chon topographic stop hi 10 degree ain son chho te to ta ni tin atira pan taka om 4.5 cm kha tu na chon hei 8 cm ra chho to ta ni chu wang chuan hei hi tu na kan Mizoram chang ni lawin Indo-Burma range om dan ania chuan achiang e mo kha achiang tura ngai la ti han anga ya le ta la tuna sandbox model kan huang han khatiang kha Indo-Burma range om dan ania chuan kan soi a technical de rek to dona helai hi hi Tripura tanga ma mi tlang dung ania chuan hei A1 A2 A3 A4 kan ti ho te hi entitline kan ti na china ale ma kan lo hu to ho khania he entitline hi han jei bung hok tai la entinge a leilu a chung ri lain thleng ti hriang tu chon hi helaya a data kan huang hian mouse cursor hi lo enila helaya data hi kan tiang kan lak feka ti han tin hemi a hian kan map a kan ti lan lo chu helaya hi sin tai na ni sin tai la pon kan dak tuan vek ani ti kha kan soi kan bel tel tua chon jei bung hok tai la hi alan dan tur chu nia hi A1 A2 A3 A4 A5 A6 kan ti hinia A6 taki jam pui tang dum chi pura chu alania ase jam pui tang dum ho omania heta phe hi chon entitline te pani kha in sutoni a complicate to ema tun heta A8 kan huwa A8 ta hian hei tut fault kan huwa he tut fault te hi tuna kan fault soi khania he hi chu ma mit tang dung nia he tut luin he fault hi azo zai ni ti ha kan ta lang le duwa hi tiang hi kan lei pon lang china kan lei pon lang atang kilometer thum vela leilu in the dan kan geometry kan zir thei te chunia tin tuna hian kan hmaba ka hi ma mi ta tanga champhai theng hi chiang taka aya chiang zo ka lati le te pokan tuma tun han paper kan poi pui me ka he hi azau zo kin lo entai la he lama hian veilam panga hian daka kan huwa e a hian daka atanga ma mi tlang dung theng kha nia chon hei leilung in thela han en re pon daka lama chon leilung hi alain thlep mang lo ni chuan hei hi Indo-Burma range a hian hei hi frontal belt an tia ahmalam pang an nia hei hi chu alain thlep ve vak lo a chan chu he leilung index or na hi ava thleng lutuk ri lo tina ni chu omzia chu inner belt kan ti hi Mizoram chung hi inner belt an nia chuan Tripura khu outer belt an tia outer belt a point hei A1 le A2 le A3 in kar te poi alain hlat em ani kan entitline te hi ma se apia lampanga chak lampanga west lampanga kan kalzel chuan entitline te po hi A3 le A4 point hei thet to A5 le A6 point hei thet to ti han A7 le A8 ai nai em to em ani chuan ti khan a chak zonga Mizoram hi kan kalzel chuan he entitline te po ai nai chil to em me ni ti chu a complicate tel ti na ni chu chan chu leilung index ona kan soi to ang khan Burmese plate in rong la ne ka wangin chuan hei hi tan bung muk taila Mizoram Agartala atanga champhai inkar chuan hei hela hian ka han thai biala hei hi Agartala nia aveilam pang top ber hi Agartala nia chuan hela ya thai bial mouse cursor a hian lang chianga ma mit hi hela thing hi kan paper publish to chiang zo ka kan ti to nia chuan adang po hi data chu kan nei vek to nangin tuna hian paper la kal mek ani wangin a jong ka rong la pho chok thelo angai thatu ten milo thiam don nia ti chuan hela ya hen aizol omani hela hi aizol zon ania ero hi kan lo hunga hela hi aizol zon ania chuan hei hi leilung in the dan chuan he tila hi ke fang entitline kan ti kha ania tin heta ading lampang atop bera khan champhai kan hunga champhai te po engwai nge zol te kan nei kan ti chu kha anhoi a hian he chorchanpur mau fold in next sor na le chung ril kan chu hu thei si lo a hian hemi hian trusting asiama mi o chumi wanga champhai le lung te poi zol ani ati te po kha hypothesis ania ma se tu na hian na ti me kan ni vaina zong kan na soi thelo mino thiam do nia chuan a topographic stop hi entaila Agartala tang hian he te kan kal wang chuan i ma mi ta tang hian ma mi ta tanga champhai in kar chu topographic stop po alo sang ta dei ta ni 0.5 degree dei ro ni to ta ni helai ne na khai kin chuan 0.1 a train 0.5 a chho dei to a tin an le chunglang kan soi ba ka hian le hnuai entinge omti hi kan hre theilowa ma se oil company te kan theiang anga tangin data te ka han dila mi han be khoma hi helai ading lampang hnuai lampang a hian kan hunga hi oil company tanga an data leilung in the dan an le chung rila ania chuan hei hi kan leilung zeibung hmuk thailand the dan ti chu alan dan tlang pui ania chuan atop lampang kalon hai to don me nga engwai nge IBR kan ti hi apoimo kan ti chuan soile soinu he Indo-Burma range hi Bangladesh atanga Myanmar inkar ania chuan he Burmese plate hian Indian plate hi alanor tom tatawangin kum khata anor chaksong hi millimeter somli paru angvela chutania chuan tuna a geometry kan zir zong hi leilung in thlep zong zong hi pot ngil ta vek tai la engzat nge lo in thlep koi to a engzat nge shortening kan ti at Indo-Burma range hi engzat at to in nge lo om to kan ti chuan kan zirna chuan kilometer somli pahni angvel alo diklo that ani pon plus or minus 8 kilometers angvel ani chuan pariat kan bel chuan somnga angvel kilometer somnga pariat kan paile chuan khati angvel anga toi to ha anga han kan ngai ni om zia chu kilometer somthum chu chuang shim don ti na nia somthum chuang chu alo toi to ni he Indo-Burma range hi ti ha kan zirna train kan han chiang thei ta tin he Indo-Burma range lo toi to na chana loin sut ngar na hi tun nai mai thil ni loin million tam tak kalta 8 million years vel kalta de tang to loin sungar ngar to ni ti kha kan han zir chwa dan chu ni le boka tin apoi mo na chan chu he Indo-Burma range a hian mi za somli million za somli vel cheng anga chu dan ni a chu wang chuan helai mun hi nging kong kan ti kha ani ve thei tatani ma se tu na hian khami nging kong ani wang han tu na hian nging hal do na nat takin nging chu teacher scale na chu na nging do ne chulai mun na chu na nging do ne ti hi tu man an soi thei lowa ni ma se helai mun Indo-Burma range a hian emi earthquake lian tak kan ti giant earthquake kan ti hi om thei tura ngai ani a he alema hian hnuai ha kan da entaila he Indian plate hi Burmese plate anei suta hian Indian plate hi hnuai lama chuk thla hi helai dot ta sen hi Indian plate ani a chuk thla chon Burmese plate hian arong lan nor ve reng ta ni chon ma se he nor tom na reng hi kan soi tong khan helai mi fault sagiang fault a sen a in thai thla te hemi te tin kabo fault te Chorochanpur mau fault hian a chak zong hi a tha halo lak chen ve wangin lir hing angin arong pel thin ta ni helai fault an pel che han lir hing te kan no nei thina ma se tuna scientist na an hlau thon le pakha chu helmi te Chorochanpur mau fault le sagiang fault inkara fault le adang kaladan fault te ho mei pia lam pa hian he Indian plate lut tha hi he lampang Bangladesh lampanga hian sediments tam takum khata Brahmaputra lui le Ganges lui na alo chep chuk thina vain a ri to ema vain hi he Burmese plate na anorna tha hi aya alo om vereng boxia a topri ni helai plate lut tha hi topria ain lok tatani chon he lok awang hian entik ala in no reng boxi chon entik minim monia chon apel ta se helai engeni Tripura le Mizoram te le Bangladesh in karvel nge khoilai takhi nge chu soifak a theilowa heng lai vel bora hian he megatrust earthquake hi om theyanga chudania chu earthquake chu lo om palta se he tilaya mat fault kan ti kan mu chu thar kan ti to kha fault a pohan co seismic kan ti he earthquake lian lo om to awanga secondary earthquake danglong siam le thei fault kha tut fault kha lo ni vere preng siama set kha tut fault kha chuan 5 to 6 magnitude earthquake item chu te chuak theilo tura a structure atang zirna chon chu tiang angai chu ni a chu tiang vel no kara om kan ni wa chon Indo-Burma range a poimo a lir hing ko kan oma zone 5 kan oma ti hi sarkar hian soi vere ka ma se voini thleng hian kan history a pol lir pui kan ta tong ngai lo ti te po zona om the ni adik chi a khatiang ha nia han ngai to wang chon ni ma se lir pui re hian cycle ania kum za thum tanga kum zanga in kara te a hing chin ani chu wang chon lir pui hi a hin lo rei to chuan a chan sa sang ve thoni ti khami pui te pon an hriat thiam ve nga ya ma se chu mi wang chon tu na thleng don tina engma om chuang lowa ama ero chu kan ti the chu lir hi rong thleng se entinge kan tiang Japan rama te chuan magnitude 7 te 9 te pon hing chang nei ma se casualty kan ti mi thi te in chia te pom ve tho ma se khatiang khopa na sa si khan mi engeni casualty kan ti kha an tam ngai lo em ani ni ma se a chan le wang chu an ni chu ma tang in lo in bot seya so khar thu soite an oya an in sak tan te tin lin hing lai om dan tu ti te lin hing huwa om dan tu li rin ma lo in bot sei dan tu ti te so khar thu an zoma wangin tu na hian casualty an tiang te an na salawa ni ma se angai thatu jong te kan cha du chu zone 5 fa kan oma kan tia zone 5 fa kan om na hi kan hlawa kan rapa hata hian kan du tok mai hata du tok mai lo hian loin bot sei te tin sarkar lampang disaster management authority lampang ina Mizoram sarkar te pon mock drill ten ne china khatiang zong zong te kha mang tangkai la tin mi thiam te thuron lai la kan in sak dan thun sang ate du na la ya du ang za za ta le lai ngota in samei lovin kan in te him to kem ti te kan ngai to don nia khati zong kha ni se kalome
We would like to tell our participants that welcome back. We would like to tell our participants that our choice of medium of our speech for today is mostly the local language, that is Mizo, because our focus is also on educating the local people. As you know, at present, many people in the eastern part of Mizoram are witnessing tremendous counts of earthquakes and are curious and scared. So for non-Mizo language speakers, please bear with us, as we shall be switching with English from time to time in the following days of our webinar. And please, our participants, please note that feedback links will be provided at the end of every day's session at YouTube pin post. Participants are requested to fill up the feedback form so that your feedback will be recorded as your attendance, so that e-certificate will be provided to you as for your attendance. In a short moment, we shall continue with the second session. Welcome back to the second session of today's webinar. Today is the first day of international webinar on natural disaster with special reference to earthquake and its implications. We are indeed very fortunate to have with us yet another eminent speaker. He is Dr. Lalrinpuia Vangchhia from Government Nathia College. Dr. Lalrinpuia Vangchhia has done his PhD from Mizoram University and specialized on environmental geography and health geography. He is an assistant professor in the Department of Geography at Government Nathia College. He has published one book from Springer, Switzerland. He has 12 research papers published in journals and edited books. Some are impact factor journal like Journal of Mountain Sciences, China, Current Science, India, etc. He has presented more than 20 papers in international, national, state, and regional level seminar and workshops, including a paper on environmental heavy metals, concept, poisons, and control at Institute of Mountain Hazards and Environment, China. He has a research project under ICSSR major project and under NABARD consultancy, Government of India. He is also a current secretary of Geographical Research Forum, GRF, Mizoram. And today, Dr. Lalrinpuia Vangchhia will speak on India, the landforms, and earthquakes vulnerability. Please, sir, the platform is yours.
As a resource person to present India the landforms and earthquakes vulnerability. So today, first of all, I like to say that my presentation will be mixed with Mizo and English language because this seminar webinar is intended to understanding of earthquakes and Indian landforms and vulnerability to the local people also. So that's why I mix with English and Mizo language. Okay. So I'll start my presentation. Share. Okay. Okay, is it visible?
Yes, yes, it is visible.
Okay. First of all, I'll start a few words about earthquakes. It is not full screen, yeah. Okay, now we already know that the meanings of earthquakes and the factor which causes earthquakes and the effects also. So for the local people, I like to say that earthquakes is due to the movement of the plates inside the landform. So today I'll speak landforms like geological landforms and zoophysical landforms. We can also say that geological means internal landforms and zoophy means external, like physiographic structures. So as we all know, there are 6 major plates under the crust of the earth. They are moving and they are very active, and some of them are moving toward each other, and some of them are go apart to each other, and some of them are collide, and some of them are beneath the other plates. So when the plates collide to each other, there is a chance, or there is a huge earthquakes, and there is a very high degree of tremors or earthquake disaster. So this is for the first time mizo trong in kan chun zom lo nga earthquakes lo om na chan chu heng plate ho hi athen ain si zong te athen ain kal san zong te le athen ain phur zong te khan kal thina chu wang chuan ain si zong an local khanin heng plates te hi engwangin nge an chet ti la ya pok kha heng plates noya hianin kan shet agin magma, very hot magma, 1300 Celsius degree velsa kha anom ta chung chuanin nge ni chet anon tum reng ta ni chu anon tum reng sia chu wang chuan heng plates hi they are floating on that nge yang khami magma chunga khan lang ani chu wang chuan heng hi an che a then ain tok zong in an cheta a then ain phur zong in kan soi ang khan chu wang chuan chu mi ngor chu lir hing alo ni ta ni in heng la ain kar hi late la hiam lake hit chat te fault te kha tiang chi kha leilo in nek tum ang chi fault folding kan tiang chi te kha aum thei ta a kha wang khan earthquake chu hei wang hian alo thina ing wangin nge place te an tol kan hre to a tin chu mi mai ba kha chuanin lei chung ri la hianin sea floor spreading theory kan lak ze chuan helai hianin tui pui chunga te po hianin tlang dung rong thang me kha om ta kha tiang khanin lei chunga kha tiang plates kan ti lo lang kha anon ti son be thina chulai chu earthquakes origin a kha kan soi zoka ti chuanin major plates oma India rama hianin ingwangin nge earthquakes si atam em ti te na kida kan la soi ze langa helai hian a chan chu India hi apart ten khathi different parts are very old topography, but some are very old kan ngai tu kan share tu chu mi zo tun kan soi le lokunga helai peninsular India kan ti azum la ya hi a upa em to ta ni amaro chu Himalayan mountain is very young folded mountain an lo ti ta enge chan kan ti chuan chu mi plates in neck sor chuak ina Himalayan mountain hi asiam ani ta chu mi ma dei chuan peninsular India chu lo om to ta ni chu wang chuan earthquake distribution hi adang lam ta doi mai ni India ram hun chen sang sang a hian chulai chu hoina kanon soi tur chu ania the reason why some parts of India are highly vulnerable, some parts of India do not face active earthquakes kha hoina kanon soi tum chu ni ta ni chuan tuna ka son soi ang khanin continental drift theory Alfred Wegener alo soi kan chiar chuan hei hi Asir ber velam kilami hi man laya khomwal puyom khom dan panji an lo ti chu ni ta ni ichuan ding lampang kilberami in the right corner. If we see this is the present continent, so we can say that the continents are moving till today. So in some source say that 0.5 to 0.9 centimeter per year, all these plates are moving very active. Kan evang kanin tun kengpo hian earthquake si kan la machon reng ta ni ti hianin recent earthquakes data karon ta langa ta hian 2010 to 2020 a hian he hi data hi kan hmu the in karinga hela hi total earthquakes recorded documented khawkha ani ta ni 2020 hi ala tam hle tu na ringot po hian even only half of the year we are spending, but we are facing many earthquakes in different parts of the world, especially in India. I'll highlight later on. So this is the world Indian ranking on the world earthquakes. India is under the top 10. That is the top 7 earthquakes vulnerable country. Landforms, I'll highlight different landforms with their vulnerability, because as we said that some parts of them are highly vulnerable, some parts of them are lower vulnerable. So the reason I'll try to highlight the reason why there is a variety, there is a variation for earthquakes disaster. First of all, I like to say geological landforms, that is internal landforms. We can say that India we can divide into 3 according to geological landforms. We can say the number of peninsular region is these parts struck by a black line. It includes Meghalaya Plateau and the Kutch Kathiawar region in the west. So this region do not face a very high magnitude earthquakes, as well as a lower number of earthquakes. It is not frequent happen, because helai part here 600 million years. This belongs to Gondwana land. Gondwana land anitani. Gondwana land belonging Cameron Galzilla Khan Yevangin. Helai Muna he few again faults canti faults de cutting lake hits at the on vevak a solid and rigid and old topography in Vangchhia Peninsular India here in earthquakes at Tamlo. Ani Alex Hongri Lapo again young metamorphic rocks canti lung chang pui clearly lung upal to any avante. Vangchhia lake heat Hatianka atam velo ani. Tutu earthquakes hazard maps kan la enanga tatang chuan ni tatang aron zirchu kanita chu ka base ani panila chu the extra peninsular region kan ti chu helaya the black dot amma kho hinitani ta chuan the eastern extension kan ti hi Mizoram te po hi achang chuan eastern extension of the Himalayas antiani sumi chu achana chu helaya according to continental drift theory, India, the Himalayan regions is due to the distortion of the 2 plates collision, Indian plates and Eurasian plates. Dikhanita. In Vanginge, eta Mizoram, hemi extra peninsular India, he had the zone in north to south, zone Dungzu Hederon Kalkantion Helahian. There is another big major plate, that is Australian plate. It falls to again northwest ang zong idaron kalavang in Mizoram Tlangdung hian Himalayan mountain Tlangdung ang law pangay ang law takhian alo umta chuwang chuan this part is extra peninsular in the extra extension of the Himalayas te alo ti chintani helai muna hi alai hall anita peninsular India le helaya Himalayan Tlang velbora velbor zong hinitani chung lai chu again earthquakes chuan India rama highest vulnerable zone kha aloni ta a Mizoram te po kan om ta a hemitlang tung zunga hi o helaya black dot chia mizo ka hi avar plaina om a hi helai bor hi ni ta ni tin pathumna chuan geologically a chuan Indo-Gangetic plain helaya in dot alai holami ho hi peninsular India le extra peninsular India in kara hian om hi engwangin nge engtin nge helai hian plain alo om ve ringot ti te po hi azir thiam chuan kan she viawanga amaro chu azir line mek le khatianga tana voin hi tangkai tura andu ani boka la hianin plain helai plain lo in siam ngun ta chan po hi helai peninsular India kan tia kha to it originate from Gondwana land in the Vangchhia peng khat khala di charsarta due to the continental drift it flows towards north marzongin akal chhauta chulai chuan it collides with the Eurasian plate chelama khomwal pui kan timeng chu plate lian pui pakhat ne na in sutani chu ai sut chuan pakhat zo kha mun then khat lai kha lut alo om ta chumi all chu alo om doi ta ni chulai chuan peninsular India le Himalayan India khalai tang khan deposition aron in siam ta ni lui emo ro emo tui pui emo khan atira mun all tuina lua kha deposition aron siam ta due to the continued deposition of sediment to the this lower basin between peninsular India and extra peninsular India. It deposits and it makes the landforms like a plain siam chuak ta chu helai plain Indian plain lo om dan tele Himalayan mountain lo om dan tele peninsular lo om dan khati khan an siang ta pot sela heng ho noya hianin lung chi sang sang again the geological kan soilai ni bok internal chunga hianin thil zo hriat chiam tak tak lahar ri ma se akuma tang ten alung chanda na tang te khanin heng lai hi earthquake chin emo lake hizat in emo leitlan yem in emo angam big lo vulnerable ang chi kha alo om sang vele thina khalaya kha rocks zong zong hi kan soi chuan array don lo to ka darkar khat o kan soi le du chu we have 1 hour for this presentation. After 1 hour 15 minutes will be a discussion. If you want to ask something anything about this presentation or beside this presentation, you can have a message so we can discuss after 1 hour presentation. So there is a different variability of earthquakes vulnerable geologically leichung leinuai lung om dana zira emo leilung chan lo upat lo dana zira earthquakes vulnerable India rama adang lam thei dan chu kan lo set ta ani it's one plain kan soi la kha Indian plain great plain ti la kha it is moderate vulnerable as compared to Himalayan region and the peninsular India. This is the middle portion. Alai holvela no many asansu there are some fault and fracture kating chi in sulpel an chi engen yang in to remlo khala om ve thowa amaro chu Himalayan tlang ang ma katiang in next or na lo ani awang khan helai mo nai chuan in earthquakes history kan thir po in Himalayan te peninsular heta extra Himalayan extension kan thir chuan atam vak lo zok ta ni chuan physiography lai hi karon thur bing du ber pakhat ani some resource person already mentioned about the fault and geological structure. So now I may concentrate on physiographic division, physiographic variation with earthquakes vulnerability. Like physiographic sanction ahian India rama chuanin 6 major divisions kan lo nei ta tlang sanga te engwangin nge lir hinga om du bi ka desert sa te lir hinga om ve toem Indian desert sa lir hinga om ve toem is there any high magnitude earthquakes in the coastal areas or the peninsular India. So why it is variety kha engwangin nge danglam ti la kha karon sorry katum tani. The northern mountain system hi amma saber o kan chen shana hi the northern mountain system te the great northern plains kan ti te peninsular plateau Indian desert the coastal plain the islands group heng ho hi tani India rama chuan in plain area hi atamber tapota maset langte paizol engen yang lui pui kam kan tiang chi cutting the desert the po makhanga khanin earthquakes thendan kha in anglo noi maya chulaya chu earthquakes hazard zonation map atangte fault and atiang map atang khan karon chui veya in earthquake result documented result atangte karon chui veya in katatang khan in what will be again the factor which make vulnerable of that particular area. I'll try to highlight. The first one is the northern mountain system. This part is formed by, as we already mentioned, the collision between the two major plates. This is the Himalayan mountain is vulnerable. This is the most and highest vulnerable area for earthquake disaster because this part is very young, only 250 million years ago. That is formed during the Tertiary period. And the Tertiary period, so kan sheveka ta chuanin kum magtadu is a songavel or so aupa. Aleni achan su Gondwana le Kalaivel heta Eurasian plate the nu de iro in next sort swak kha ani kan ti wang khan ama chuanin ngani tuipui na khuvek ta ani tuipui chulai tuipui chu te thisi the thisi ina a khuvek ani awang khan alma in alaron lang chuak lo ta ni ichuan tun hai me zir chen na chuan the recent study believe that it is still moving marzongin alatol renga chu chen mun chen kada chuanin 5 to 9 centimeters the point kan hu fo mai thei amaro chu helaya hianin 5 centimeter per year tia hi atlang lon karon mu ani a chu wang chuan he helai landforms hi 5 about po kan ti about 5 centimeter per year alatol reng tani in zone 5 earthquakes zonation kan ria earthquakes zone chuan helai hi highest vulnerable area zone 5 and sometimes some places are under zone 4 zone 5 le 4 akhan om shim ta in helai hi fault and tectonic crust kan ti kha helai mu hi atam em mai ni me pa hian kan mu theyanga he Punjab Himalayas hi the western portion of the Great Himalayas nitani ta hianin lei khichat ti te khatiang lei in pel so fault khatiang kha atama wang hianin helai hmuna hian lei chetur khatiang plates kan tia khanin plates major plates ti te te kha ala vele zela khalai noya khanin hemi Punjab Himalayas noya hian atam em tani chunga chuanin neo tectonic fault ti hi tel pokani chumi zia chu khami lekhia khanin apong zong le akhor zong de te khan theita chu tiang po chu wang hian helai mula hian earthquake si athen ol sambi kani khang kha atlang kha ala che reng box ya wang khan in chu tiang che chuan earthquakes magnitude sa na chan sahi heta hian asang bani it is vulnerable very high vulnerable with a high magnitude earthquake ta hian dot sen helai sen kan mu hi the red dot indicates 8 magnitude 8 and above 8 or above magnitude tikhani tani helai hian Punjab Himalayas here in 7.8 magnitude in the region of Himachal Pradesh in April 4 1905 hian alo theng to nge ya it proved the vulnerability of these particular landforms. Why there are numerous fault and fracture and neotectonic fault and neotectonic thrust. Because of this is not very rigid. This landform is not very rigid. It is mixed with different minor plates, or it is the distortion of the two plates, and that result it is not solid, and there are many parts. There is fault and fracture. Kaka lấy khizat om na chan helai bor and lấy khizat om na chuan lir hing kha alo om thei zel ta ni chu wang chuan Punjab Himalayas is under the zone 5 of earthquakes vulnerable zonation. In next zone Kumaon Himalayas, this is Uttaranchal, the states of Uttarakhand or Himachal Pradesh. But here we can see that there is not a very high number of fault and neotectonic faults, but some neotectonic faults are there in the black lines indicate that this fault, but this is not highly vulnerable as compared to the Punjab Himalayas, because of this is very close to the Indo-Gangetic plain. As we already mentioned, Indo-Gangetic plains, there is sediment deposition, and it is like a gentle, and it is like calm areas. So helai mun na yani wang hian helai vela hianin fault le fracture vela kha atam lo ta chu wang chuan Himalayans lang ro wa chuan Kumaon Himalayans anti helaya Punjab Himalayas bulchi kan hu mepa kan hu lai bor hi tlemin sang vak lo record po sang vak lo in Assam Himalayas hi we are very close. Mizoram state also very close to Assam Himalayas. Laya here zone 4. This part is under the zone 4, and Sikkim, Arunachal Pradesh, and Assam includes are under this landforms zone. Here we can see that fault and normal fault and thrust are identified in many places. We can see the red lines are the normal faults, and the red dot lines is the fault line, and the black lines are thrust lines. So they are very close. Faults are also very close to each other here in this landform. So that's why there is a very high vulnerable, very high chance to have an earthquake disaster for the future also. And based on the earthquakes documented data, very high magnitude earthquakes, that is 8.6 magnitude in 1950 happened in Arunachal, Assam and Arunachal Pradesh, 6.1 magnitude in very recent last year, 2019. And also these parts 5 magnitude to 6-7 magnitude earthquakes are very commonly happen in these landforms. As we see the black circle, the smallest black circle represents 5 magnitude in the map, and the larger one represents 6 and 7, and the red circle represent the 8 magnitude. So we can see that earthquake documented spot area in these landforms in this Himalayan Assam Himalayas. Helaya hi rin kwalvar ate berahi 5 magnitude. Chin chiana khani ta kan en renga hian hei 5 magnitude hi atheng 5 magnitude vel bor chu atheng reng mai ni helai hmuna hian achana chu helai hi plain continent khan ang le to che silawa Himalayan mountain ang zia pian thau khan ya wangin fault and fracture khatiang kha alo in siam tam alo tam ta ani chumi ni chuan earthquake sa kha thlenna chan sang big tani in the provincial Himalayas kanti provincial maybe also parts of the extension of Himalayas or yang Patkai Hills ite helai tlang tung hi provincial Himalayas chuan northeast India. This is the highest earthquakes vulnerable zones. Engwangin nge helai hian earthquakes athen na chan sa sanber na chana chu hey han amep han enila fault lines te hi ain kal pel zung mai de mun sang sang hian atama tin na china kan soi le khizat pelama le rol remlo apong zong le hoi zonga in kal thel neo tectonic faults kha tam tak aum bokani achana chu this part is from the theory of continental drift and plate tectonic theory. So me chang chuanin this part is more or less younger than the major Himalayan mountain landforms. Elahi ala upala vele chong achan chu kami Eurasian le Indian plate in sud nu khan in sud nu lam khoya khan Australian plate na aron nor tom vele kha helai bora khan ye wangin helai hi ngani fractures kan ti khatiang fault kha atam le khi le in pel sol le rol rem lo kha tam ta chumi ina en tir pakhada chu there is a chance of a very huge earthquake sikhani besides the frequency, besides the occurrence frequency, it also indicates high magnitude. The kind of severe earthquakes theta. So that's one Silonga po 1987 ahin 8.7 magnitude kan 8.7 ahi tamtak atheng lem lo kumtin hianin voinga imo vel hengai portion here thing chawa tu tiang zinga chu heng hi 8.7 te 9 thing kan hol thei zinga tel ta dai tani tin plain khang kha Himalayan mountain selai tlang dung lian zuala earthquake sing vain nge a then thei big nge asan big na chan the reason why the Himalayan mountains are highly vulnerable ti khalong ita se panhina chuanin and the northern plain hi dan en lenga northern plains chu helaya asena in mark ho hi along ita na china kan so yang khanin Ganga te Indus te Brahmaputra te khanin deposition ansiam atang khan plains hi aron siam zela hangai tu ta ila hetia plates in pur khwala taka thil in deposit kha ani ta ni it is medium moderate poti theng chu as compared to helaya tlang dung tak ai khachuan tle min ala name deu ala zentil ala thamwang deu ani chu zone 3 le zone 4 a hian anda ta ani earthquakes hazard zonation map kan endpoint zone 3 le zone 4 a here our moderate high to highest vulnerable zone ka ani tani heng hula hianin fault te hi entin nge awm ve thei khatiak deposit tia sediment deposit atanga lo in siam ni sia khan fault te po kha awm ve thei tho tani achan chu plates anin sik khanin tuna hianin lekhabu emojir chian na tak thei ni che khoi zong nge Eurasian plates zo ka hi nge tol liama kami gondwana Indian plates kan ti zo kha khoi zo khen nge phur ti hi lo chut ta ila chumi a in phur chu ala che ve shat rengani chu wang chuanin moderate to high magnitude of earthquakes ti kha a thleng theya la map a hen ta ila the northern plains a hi engin nge characterized kan ti so it is characterized by the fault lines but it is not many kha atam viau lo tani han enila hi elai Uttar Pradesh ti insi kan mo helai ing tak zone lai vela hi ani tani zone 4 chu zone 3 chu tlema ing tak bulami hi zone 3 hi ani heng lai vel bora hi northern plain chu ani ta ni hengla hianin rin a intimela helaya abulok the neighboring mountain areas are here in fault lines the atom view lai hian helai hmuna hi chuan akhat phar tani han enil akhat phara lekhichat kha awanga chu chu any common general takin ka enge tlaya kha earthquakes thlen thei na chance kha hundang ai khan na china kan soi do hundang ai kha chuan atlem ta ani awm zia chuanin chu khatiang lein ro rem lo tam na lai kha earthquakes tam na lai tur chu ni maya helaya black circle hian entaila henglaya point earthquakes hi alola theng tam lo hemi record hi kida kan lein nga nunglama khalaya khachu the great plain chu kan share dan tur bera chuan Himalayan mountain te ang ema earthquakes are vulnerable lo ta chana chu sediment deposit mai kha ani ta lungchang in next sol om khom rup ang kha ani to lo wangin lain phurve der ang kha ya wang khan again moderate to high zone khan aloda ani chuan the great Indian desert hi aloin siam dan kha kan share thau chu rin om nine momo kalo om ta ngan so the great Indian desert chu thar desert kan ti mai kha ni ta helaya rin sen line sen kalruya hemi laya hian hemi parallel here in Aravalli mountains kha om ta ni as we all know India is getting drains supply very huge monsoon or very huge rainfall by monsoon winds kan ti khanita southwest monsoon kha Aravalli mountains hian alo block tatlat maya helai Aravalli mountain pia chi hian in thar desert kha ruwa tuidong lo ram laya kha alo om ta chu ro tui tlem em wangin helai hian desert khalo in siam ta ni ta chuan khovela nge ni thaler zauber ber pakona khalo in siam ta hiala helai hmuna hian earthquake si atheng vem ngani this part is very different based on the physiography atang so adang lam ngal nal ta maro chu based on the earthquake's vulnerability is its difference as compared to the other the klaya kha adang lam na chu hey ame pa hian earthquakes records here atlem many helai mona hianin so this is under the zone 3 earthquakes hazard zone is map zone 3 waya an omta earthquakes hitlem te so omamaro chu sang khazako somko pakhala khanin 5.5 this is the highest record in this area 5.5 so even in some small state in the northeast it is very common so we can think that why this is not highly vulnerable and this is safe this part is we can say that it is safe from the high magnitude earthquakes in Vangchhia kan ti chuanin here there is the next part the next neighboring areas in the western part is not a mountain it is also again plain it is extended to plain toward Pakistan kalai plain phezu ye hinita Aravalli mountain hi tlangdung alo vele to mai helai shu la hian again tectonic thrust kan ti khatiang fault kan tiang ka tlem he red lines kan hmu tlem ve chau ta ni chuwang chuan it is very similar with the Indian plain ang mai khalai ang leis ngani sang lo lei chang rual tha kha an nia khatiang ani awang khan earthquakes thlenna po hi thlen chance po hi asang viau lo ta earthquake zone 3 anom ta ni Peninsular Plateau lai hi danglam hi engeniang one of the most old and again varied topography among the physiographic divisions of India adanglam big natsu upalutuk mai ahinita 600 million years well laya upa dei to khan helai mapa kan huang hian India hela Himalayan tlanga siam ha dei panji helaya amum khovel lem kan mu he lai chang hian alo om dei to ni chu wang chuan he lai leilung hai au pa mmb ka hi adang lam na chu ni ta khovel anga po khovel ram upalai ber te sing mi nya aroksa a leilung ate po hi metamorphic cho kan te lung chang pui pui kha ani wang khan adang lam bik le zual ani India hi kan soi angin ram zau tak le ram dang lam engani ram bung sang dang lam tam tak kha ani ya ta chuanin helai hmuna hian helai peninsular India hi earthquakes a hian a hlaum ve enge a thleng ve to thinem enge a chan what is the reason ti kha kan highlight le zoi anga ta chuan peninsular India India among the divisions of physiography of the continents, it is the most safe divisions to earthquakes. Achana chu it is very solid kanti to khanita alo angeni asakhat ma katiang besides the earth crust there is magma they are trying to again spread outside katiang khan anon ton tlang zolo helaya hemi nganing leilung sakhat pui mai hi anon ton tlang zolo ani chu wang chuanin helai hmuna hi a upa in a solid tin fault line kan enanga fault line te khatiang chi tectonic fault kha atlem te reng ani chu wang chuan helai hmuna hi atam lo earthquake sa chuan a vulnerable ta vak lo ta India rama chuan him lai ber poni theya chumi ni role ro chuan he earthquakes data hian an enjoy taila 1998 hian 5.5 te tin 1843 hian 6 magnitude tin decan plateau hian alawong beto helaya gondwana lan hemi peninsular India hian alawong veto ti chawani chumi alo chuan 5.5 magnitude chunglam hi record a common ve vaklo ani mundang angin chulaya chu helai dang lam na chan chu lo ni ta se the coastal plain the fifth divisions of the physiography of India here the coastal plain here it is the corner of the peninsular India helai sirte te mai kha ania maro chu peninsular India ne hian earthquakes vulnerability chuan ai angle mi silo ni achana chu tui pui kam hei an entaila zone 4 anom le dei sini zone 4 te a then chu zone 3 le a then lai chu zone 2 te polom theita zone 2 kan ti chu moderate the maze risk zone khani ta zone 4 te page chu angani high magnitude ti lai khani ta chu wang chuanin enge danglam chan ti le earthquake sa hianin a vulnerable em ti lai kha this is a part of Gondwana land chuni ma se it is the corner and the boundary with the Indian Ocean helama Arabian Sea and Bay of Bengal ina akwam in tani chuan helai hmuna hi ngani Gondwana landforms tengai to chuanin a solid low zok in fault line hi a omve chek chuk mai ni helai lei tui pui force te po ani thei mai thaya helai hianin fault line kha a big takin hei red dot line dewa kal nim ne hi atam chu Gondwana lan helaya peninsular India nen ain an lo na chu ania tin maro chu earthquakes sang tak ero chu atam chuang big lo maro chu earthquakes hi helaya hi higher than the ngani peninsular India kha chu ani ta tho honi nang reng in zom reng sia kha landforms kha yang lo ve ta chung jinga chuan hei 1905 magnitude te 1953 5 magnitude in Kerala te alawam to boka tin 2000 khan 5 magnitude in Kochi alo theng to bok ta ni chung omna chana chu hei kan hu angin ngelai hian fault identified ta hi tam tak om ta a big takin eastern coastal area here in atamani eastern coastal area hi country to chu helama apia here in the minor plates le Australian plates te in rina lai kha alani ve wang hian helai bora here in engani khatiang le tui chunga khan le sakhat lo te meang fault ang chi te kha alo om ru treu ti na ni chu helam Western Coastal Plain a ero chuan atam le lo thung ta achan chu Western Coastal Plain a chuan Lakshadweep Island chia te hi om helama hianin plate nai vai lu tuk kha aw lo wangin helai mun hi a him Western Coastal Plain a hi earthquakes a chun a vulnerable lo jok nge nge ani chuan islands group a hian physiographic division a chuan a top na ber ani ta islands group chu the Arabian Sea, Andaman and Nicobar Island, and Lakshadweep Island. There are two islands groups. Is it vulnerable or is there any earthquakes vulnerability horizon? Andaman and Nicobar Islands, earthquakes are highly, very highly. Ani top me a vulnerable earthquakes ni a hengring angani enge achan kan ti chuanin helaya hian Andaman and Nicobar Islands it lies between the Indian plates and the Australian plates. Plates in kara umta Australian plates hi let's say veringa India plates po hi no zogin kalma se helaya hi achet miau chuan hela islands te po hi an angeni an solid thei talawani chuanin Andaman and Nicobar Islands group hi highest vulnerable zone khan anlo ta hiela chuanin again besides the frequency again the number of occurrence, the higher magnitude of earthquakes can be detected in this Andaman and Nicobar Islands group. For example, 2003, again 9.3, it is very severe earthquakes, 9.3 magnitude in Lalrinpuia, and 2012, 8.4 magnitude and 8.2 magnitude, or 8.2 magnitude of 2012 have been documented. Circle it is Andaman and Nicobar Islands group is full of earthquakes zone circle here it is highest vulnerable in the physiographic divisions of India, but the Lakshadweep Islands there is no huge earthquakes or there is no record of earthquakes in this area because it is free. We can say that it is not disturbed by any plates. Very forceful. Kalayaka, Andaman and Nicobar Islands group angkan plate in kara ve in anok velo avang khan helai mun hi earthquakes ka atlem le tani chuan no severe earthquakes kami 5.5 magnitude isa there is no record even till today when ni thing hian helai mun hian in 5.5 chunglam record page ala omlo hial ni chuan helaya islands ro pokha ain anglo thei hle ti kha earthquakes vulnerability horizon kha kan highlight ni le ta sela chuan atlang pui thoin kha physiographic division na te ya khan adang lamna earthquakes vulnerability adang lamna kha lo de le ta sela minute tiangan local do ya helaya earthquakes vulnerability the whole India zog hen khai khom don ta ila India rama hi earthquakes vulnerable ram sang zinga chuanin top 10 zinga tel char ani achana chu gan soyang khanin tectonic plates here Indian plates te plates dang tenen in om fin na lai bora kan om wangin India rama hianin Helai Australian plates te Philippines sea plates kan ti major and minor plates hian wal chop awangin a vulnerability hi asang phot mai ni ta chuanin India ram pum atangala ka 58.6% la hi earthquakes are chuan vulnerable. National Disaster Management Authority ina achut chu azir chian danin India ram hun angeni azat ve item dei hi earthquakes vulnerable an ngaya chunga chuanin seismic zone around siam ta helaya here in India rama earthquakes then highest vulnerability te hey ascend the red color is highest vulnerable helai mun ze la hi asang ber earthquakes higher magnitude and higher chance of occurrence kha ta eng la ya hi eng tak de wa hi zone 4 ania zone 4 here in high damage ani ta helai hi nge ni chiat na sa tak thleng ve thi lai chin achu ni ta eng tak lai chu ma pa hian kan ria Himalayan mountain kan ti lai te helai western parts of India near Mumbai helai vel te tin Gujarat bul lai vel bor te tin Kolkata in the eastern part Kolkata ti vel te ho hi a huam ta zone 3 na hi akalara eng pa ngai helaya kan soi zone 3 helaya in kar bor hi Gondwana lan hemi peninsular block ngeng solid rock slab in kara khang ho lai vel kwal vel hi zone 3 along ita moderate to high damage zone kha anita atisuanin zone 2 na hi himbera kan ngai kha helaya solid rock slab lai zone kha anita engwang zone 1 hi to lo kan ti chuanin 2002 BIS Bureau of Indian Standard inati angin le national kami disaster management authority te khanin zone 1 ai chu earthquakes thlen ngai lo naram ang dewani wang India rama chuan thlen ngai mi lo na tak kha ong lo wangin zone 1 hi an ti to lo an pai ta hialani chuan a zone te hi han kan kal thuak anga zone te hianin zone 5 ina ahuam aho khachu hey Kashmir te Punjab Western and Central Himalayas and Northeast India te run of cuts kan ti ho kalai bor hi ani kumsom nga chungin voitan dak helai muna hianin earthquakes with higher high magnitude kha atheng zone 5 high zone ani ta julai chu helaya physiographic division sa chuanin the Himalayan mountain range lai ho kha anita enge achana chu kan soi vek to ta hianin alo in siam dan atanga han chut te po angai ta alo in siam dan atanga kan chut chuanin helai high risk zone chu young folded mountain khalai plate in su kami omna lai borani awang khan in si alo in siam dan atang rim khanin nge ni aval a chereng ani ti kha chiang ta helai po he kan ngatin zone 4 hi zone 4 a chuanin heng lai bor tlang rul Himalayan tlang tho ni ma sela plain ne na in kar bora khang lai bor kha anom ta Delhi te Jammu and Bihar po hianin higher magnitude khachu thana chan su aum tho da ni ma se ingwangin nge yang due to presence of fault chance kan ti le nge ni wall remlo le khi kha te nga tam wang khanin earthquakes with nge ni highest ni lovin patiang 5 to 6 magnitude kha tam ta zone 3 hian helai Andaman and Nicobar Islands kan ti te Kashmir Himalaya khatiang ho kha anom le ta henga po hian in wangin earthquakes zone 3 ani thei that's hana khachu na chi na kan soi to angin helaya again tectonic movement in a aron result a khan fault and fracture kha atom ta kha Vangchhia ani ta a zone 2 a hi India rama again earthquakes vulnerability kha anhiam na ber ani a chan po helai tectonic fault fault anti ang chi te khan helai mun hi ati boi phak viau lo Vangchhia ani ta atin so helai hi atop lam nai na tan ingwang nge again as the whole India is vulnerable to earthquakes kantia kha India landforms is penetrating through Asia kha again Asia lampan khan alakal reng wangani ta it is 44 millimeter per year ang emo le anti-clockwise zong helama khain alache ring awangin India rama kha again hle ani lo tani hle ni lo it is an active landforms and so it makes the country the landforms vulnerable ikha ani maya chu engwanga chenge tia chu kan soitoa leichung ril leichunga engani the hot temperature the hot magma ti ina aron ti chet le plate movement la in continue reng awangte sea floor spreading lo zel awangte khatiang khan aron che ta chu wang chuan India rama hianin lai hi kumtin hianin India rama hianin 8 magnitude ti te 9 magnitude ti te 6 to 8 magnitude ti te hi kumtin hian a thing renga tin 2017 a hianin earthquakes thing ringo the hitun nai recent deuh hlek data kan khona changchuan voi zani somni paruk lai during the 2017 a khan hiala in 2023 up to the present a hianin za somni pasari la kha earthquake si India rama hian a thing to atuna china record ma se heya hi we are very lucky because these earthquakes already we have past cross is lower than 6 it is not severe kha kan van nei na ala ni ria ma se voi za som hi pasari lai hi ara major ni si ani so minor page 1 helaya 3.4 ni lovin hey 5 magnitude han cross in kha the 6 apple low 5 to 6 ani so moderate kha alo amaro chu minor earthquakes anti page tam tak khe omanga thil ti che pui thamang kha kan latong tam lo zo khialani tin in the MA National Disaster Management Authority here in 58.6 58.6% of the total geographical area is very vulnerable to earthquakes around here. Helaya kan hun chen kada chuan 56 te anti bokamaro chu National Disaster Management Authority is very reliable data hani tin population ang zong in mo ka aram ang zong in 58.6 ka vulnerable ni pa population ang zong chuan in helaya hian research pakhat IIT Hyderabad with the help of IIT Hyderabad they have deep research about earthquakes prone population khan in 2016 4 out of 5 people are under earthquakes threat in that stage in the Hyderabad achana mi pangazela pali hiala kha earthquakes in affect he din huna anding here ni achana so due to the again yang settlement population katiang che ganomna azirte types of house construction achang zong achang anti khanin earthquakes actual population vulnerability kha asang India ma jo sang tabokani chuan National Earthquakes Information Center chuan 20,000 earthquakes per year tikha and 55 per day the total earthquakes from the minor to the major earthquakes as one. Kumtin here in India Ramachuan, hey, no National Earthquakes Information Center. In that way, Kumtin seeing 20,000 earthquakes occur and approximately 55 earthquakes per day. The khani kum somli palikal ta chung khanin from 1973 to 2017. So that National Earthquakes Information Center records in Atalandan, and it indicates very again low occurrence in 1976. Here 1990, 1995. Only 11 times so ka anmu hela hi mak viang reng khom ya maro chu 2010 chuan again magnitude 7 ai sang rekon pu kha voi som ni pali a thleng le thunga hey boy hi engwangin nge in some years many 44 years te hian earthquake sang tak thleng si lowin nge mani chang hian earthquake sang tak hi a thleng zut zut ho si a chan chu when the plates move and collide kami alo in sut to kha chuan after shock emo tikme secondary shock ang chi te primary action ba khan secondary khan azui secondary force khan azui china tin tuna po hianin Mizoram earthquakes te kan thian te an ron soi lenga hetianga te po hianin in ai siam rem chunga te hi alo plates lian thama chuan plate lian thama chuan in ai siam rem chung ringot po kha ai siam rem ringot po kha high magnitude kha lo tling thei thina chuan chuan in 2010 even in the single year kharin 24 earthquakes with 7 magnitude kha a thleng dai thei tani chuan cities Indian cities hian higher vulnerability zones hi an siam le ta National Disaster Management Authority IIT tena IIT Hyderabad tena an siam chuan Indian among the Indian cities Aizawl this part Pithoragarh Srinagar Uttarkasi Nainital and Bhagalpur these are very high risk city highest parts kita airline muna hi Indian cities in chuan again due to their settlement patran tite ngan yang house construction kha zong baka due to landforms characteristic of Vangkhan airline muna hi asang bera medium hazard with high risk alani thong high risk chu Darbhanga Ghaziabad tite Itanagar Guwahati tiang Shillong Kohima Agartala Chamoli Jammu and Mathura tia hi medium hazard with high risk zone anomlia in high risk with exposure cities kantia here Aizawl te Solad Gangtok and Vijayawada dekhanom vela medium risk with high exposure as well Ghaziabad Pune Mumbai anomatin high risk with high vulnerability helaita ka hi poimo this part is high risk with high vulnerability there is a high chance and if earthquakes happen in this area the disaster will be very huge and there is also a high chance to occur. It includes Simla, Aizawl, Pithoragarh, Nainital, and Uttarkasi. All these parts are fall under the Himalayan mountain range. Then medium range with high vulnerability are Darbhanga, Patna, Mandi, and Chennai. This is some parts of the peninsular and the middle parts of India. In top 10 worst earthquakes in India, we just have a look and we will not discuss, and so we can start the discussion and question or any interaction. Top 10 worst earthquakes in India. The first one is in the Indian Ocean, 2004. with a magnitude of 9.1. And some records have 9.3. So that's why 9.1 to 9.3 magnitude. And Kashmir earthquakes 2005 7.6 magnitude, and Bihar and Nepal 1934 8.7, Gujarat 2001 7.7 magnitude, and Kangra 1905 7.8 magnitude, Latur 1993 6.4 magnitude, and Assam 1950 magnitude with 8.6 and 8.1 in 1897. And Uttarkasi 1991 with a 6.8 magnitude. And Koina Nagar December it is 6.5 magnitude December 1923. 4 and 21 a.m. So all this discussion I can share to you today about the basic understanding of India landforms with earthquakes vulnerability variation based on the geological and the physiographic landforms characteristics. And if anyone can comment, or you can add some additional information or some comments. Thank you.
Thank you, Dr. Lalrinpuia Vangchhia, for enlightening us with your in-depth knowledge. I believe today's webinar will surely update our knowledge and answers many of our questions. Well, today, to our viewers, our participants, feedback link has already been provided. So please fill up so that your attendance is counted for your e-certificate. Feedback link feedback link kan lo provide ta pin YouTube pinpoint da kan pin post da kan so ta chuan in feedback khalo fill up pula ki chuan e certificate ta in attendance tour kha kan lo record don ya. And if you have any questions, please drop your questions and comments. Well, we shall conclude today's sessions. I would like to end this webinar by thanking our resource persons, all the participants and the organizing team. Please join us again tomorrow at the same time. Thank you.